Today's video is sponsored by PCBWay, where not only can you get beautiful PCBs made, but also do sheet metal fabrication, CNC machining, 3D printing with all sorts of exotic materials, and a whole lot more. Check them out in the link in the description. Hey everybody, how's it going? This is Patrick with Stacking Layers. Like the title says, I'm going to be showing you how to set up CANbus on the Bigtreetech PAD7. So if you've been struggling with that, or maybe you just found out about it and you want to get it going, check it out. This is the video for you. So before we dive too deep into this, I do need to point out one main thing is that with the built-in CANbus system, it's running on SPI. So as you can see here, this port says SPI and this port says CANbus, but they both rely on SPI. The downside is that if you have to use a SPI, for instance, if you're using your accelerometer that it came with on here and you decide you want to keep that going, you don't want to get rid of that, unfortunately, you're not able to use both at the same time. It's an either or situation. So if you must have something on this all the time, you're not going to be able to use the CANbus along with that, unfortunately. But if you're not, we're good to go. Another thing I want to point out is I'm going to be doing this demonstration with the CB1 built in, but this is nothing unique to the CB1. This is just the board that, well, one that I have in here, but also I think it's still the most commonly supplied compute module for this thing. But if you have a Raspberry Pi CM4 or Bigtreetech's new CB2, the upgraded version of this guy, then everything's gonna be the same. It should all still work, okay? I will also be demonstrating with the EBB42 that I have here. Again, for convenience, it's because obviously you see it's not connected to anything. And I already have a wire with this plug set up, so simple, right? But again, just like with these, it's nothing unique to this setup specifically. All the things I'll be showing you are gonna be translatable throughout whatever devices you want to plug CANbus into, okay? So with that out of the way, let's jump into the first main hurdle, and that is getting the Linux system on your compute module set up. I'm going to continue probably calling this compute module, but this is referenced as the host computer if you did not know. So anytime you see host, that's what this is. So we're going to get the host set up and ready for CANbus. So let's jump over to the terminal and get that going. So here we are. I'm just using PowerShell at the moment to get in. It doesn't really matter which terminal you use to get in. You just want to get into the SSH secure shell, log into your host basically. So we'll just do the SSH, and we're using the BQ thing here. Let's get it logged in. Password is BQ for this as default. And we're in. Okay, so once we're in, first thing we need to do is make sure that things are set up for the CANbus to actually communicate. There's several ways of doing it, but I'm going to be showing you the more up-to-date version, basically, is what it is. So you want to make sure that a couple things are enabled and running. So you want to make sure that your network system is enabled, and it's a really simple command. It is just sudo and then system ctl system ctl, and then you want to enable it, and then system again. What is that one? It's system D, yeah. Network D, make sure the D is at the end there. All right, and then we hit enter, and it makes sure it creates everything, sets everything up, and you're good. Done, pretty easy. Next thing we want to make sure is that it's started, because even though you enabled it, it may not have been started, so you just go ahead and use that. You can hit up to come back to the last command. Instead of enable, we want to start it. So we'll get that going. No response is a good response in Linux. I know it's kind of confusing at times, but if it just pops like that, that means that it was good, because basically it'll reply with either a whole bunch of stuff like it shows because it did multiple things throughout here, or it will give you an error. So popping up like this is a good thing. Okay, I just cleared out my screen to get that stuff away. And one other thing that I want to do is, because we enabled the network D service, that enables some other features. Now, this part is not CANbus related, but it's more of just to get rid of an annoyance, because when you enable the system, the network D service, what it does is it actually enables a bunch of other little network features, and one of them is the wait for online. Basically, what it does is it sits there and it waits for quite a while to make sure that everything's connected, like you're connected to your network and stuff like that. And that's at the boot up. So when you first start your system up, it can take quite a long time before it starts. So it's not really an issue with these type of systems. They're going to find the network and boot up, but instead of waiting to use your printer for it to attach online, is going to just disable that one. So to disable that, what we use is sudo system ctl, and then we want to disable, what is it called? The system D, and it's dash, not period. Yeah, network D, and then the wait, and another dash online service. Okay, so make sure it's typed out like that. Hit enter, and it removes that online service. So it's not taking away your ability to go online. All it's doing is just telling it don't wait to boot, basically, to finish booting until you're online. So anyways, enough of that. Again, like I said, nothing really to do CANbus. It's just to get rid of an annoyance that can happen. Okay, next up, we want to set up the transmit queue length. Um, this again is very different than my previous videos, but it is the more new way of doing things because basically what I'm showing you now is going to be things that are going to be more forward progressive when things change or get updated in the future. So anyways, so this next one, I'm going to just do a copy paste because it's a long command. And yeah, you don't want to see me type that all out because like I said, it's a long command. So basically what all this is doing is just setting up the transmit queue length, which is right here. And it's setting up into a new file. So it's taking this information, putting it over here and so on. And it's just setting it up for us. It's pretty simple Linux stuff, but yeah, it can get confusing to try to explain it all. Really not important, but just do a copy paste on that. It'll be in the description. But what we're doing right here is setting the CAN length to 128. Now it's a low number than what I normally use, but it is now the overall recommended, even recommended directly by the dev of Klipper. So might as well use what they recommend, right? Typically I use 1024. You can still use that. It works just fine. But it's up to you. Either one, I've tested both of them. They work just fine for me. But some people have a problem for some reason with the higher speeds, or sorry, the higher transmit lengths. That's basically all you're doing is how many bits of information you transmit per tick of the system, like as the clock is running. And surprisingly, CANbus is very small in the packets that it sends, so it doesn't really need that much. The lower, the better. Typically, there's less chance of things getting lost. So less chance of things like the timer too close error that people show occasionally on the community if you follow along. But that's up to you. Anyways, so just copy that in, put it in, hit enter, and it will be done. That's it. It shows it. You can check it if you want to. You can use the command cat, which is concatenate, and then look into the file that we just made, which is, we got etc udev, and then we did, what was it, rules, d.d, and then we did the 10 can rules. And if you enter, it will show you what's inside there. So as you can see, it put all of these four main things into that file. That's all it did. Pretty simple, right? Maybe not so simple, but easy to do. So the next thing we want to do is to actually set up the CAN network. So this we told it how fast or how much information it wants to send per thing that it does. And then now we want to say, well, who's going to be actually using it? We want to do set up the CAN 0 interface. All right, again, it's going to be a copy and paste because it's a very long thing to type out. So I will just push this in here. And it's doing relatively the same thing. It's echoing in, which again, echo means to just put this somewhere. If you do just echo without anything more, it'll just print it back out to you. It'll echo it out. And so what we're doing is we're making a name. So we're looking for any name that is CAN something. That's what the little star means. So CAN anything. And then we're going to set it up as CAN. We set the bit rate. The bit rate is that important number that we'll point out later. This is the 1 million or 1 megabit. It's the one with the 6 zeros, right? And then we want to make sure it's got a very low restart. Really not that big of a deal there. And it doesn't require online service. And then we're putting it into the CAN network file system. Copy that in, hit enter, and it's done. Again, you can concatenate just to double check. And that's going to be in that file, which is the one that we just did right here, right? It's going to be inside this file here. So that's the etc. We put that into the system D, we got network, and then we did the 25 dash CAN network. And as you can see, there it is. That's simple. Okay, so it should be all set up and ready to go. Now, the important part is once you've done all this junk, you have to reboot your system to actually implement it. So you just do a sudo and a reboot now, not reboot. So it's closed, it's rebooting, and then we're gonna have to log back in. So give it a second to boot back up over here. Okay, and we log back in, and we're there. All right, so let's clear out the screen. So now we're all set up with the CANbus system, but now we need to get the firmware for this little guy set up. And to do that, this might be a familiar thing. We're going to be using two different things, the built-in Klipper firmware make command, of course. But before we do that, I'm going to be recommending to put Catapult. Catapult is a bootloader, and what that gives you the advantages of is that you can flash updates without having to come to your board and plug it in like we're going to be doing the first time here. So you can set this up, and once you have it all set with Catapult, you can flash everything via CANbus. So it's a very convenient system. So even if you don't want to do this, hooking up your little tool boards, you can actually hook up a regular controller board like an Octopus or whatever, and you can still use it through CANbus only and flash it without having to push any buttons or put it into boot mode or anything like that in the future. So really nice, convenient feature. So I highly recommend using Catapult. So let's get that installed. First things first, we need to make sure that your system is up to date. So it's really simple of sudo apt and then update. You want to first update the list. Update. And then you can use the and. That means to, after that first part is done, do the next part. So you'd also want to do a sudo apt upgrade. Upgrade. This is just going to go through and make sure your system is up to date. And then you can follow with a -y. If you basically the -y says just say yes to anything of installing. It's just like an auto install ball. If you don't want to, you want to read what's going to be installed, but leave the -y out of that. Okay, but just to do things quickly, since I'm just going to update everything, stuff like that. Hit enter, and it's going to go to work and do the update. I suppose it helps to spell upgrade properly. So let's just get rid of this part here. Up with an R. Upgrade. Upgrade. Goodness. So now it'll update. Upgrade. Okay, so once you're all updated and everything is good, the next thing we need to do is to make sure that you have Python serial installed. This is something that Catapult, I believe, needs. So again, a simple command just of sudo apt, and then we want to install Python. System should have Python 3 already installed on it, so we're using Python 3. Yeah, so we got to install Python 3 and Python 3 serial. And we hit enter, and it's going to check, build, and do its thing. And you want to just hit Y for yes. Now that's all done. Now we get to install Catapult. Catapult, what we're going to be doing is pulling it from the GitHub. So you want to first check that you have Git installed, and again, another apt. So if you do sudo apt install Git, it should already be installed, but it's good to just double check to do it that way. So install, and then git to git, and then you just do the -y to say, yes, just do it. And it's looking for it, making sure. And as you can see, it says it's already the newest version. So we're good. So now that we know that we have it, you can actually, a lot of times things come pre-installed in your system. So you can always just check. If you just hit ls and then enter, you can look. So as you can see, we have QA, however you say that, but we don't have Catapult, right? So there's no Catapults in here. So that means we don't have it. Then we need to install it. So to do that, what we want to do is to clone the directory. You want to make sure that you're in your home directory. So you just do cd and then enter, and that makes sure that you're in your home directory. And then we want to clone it. So it's the git clone. Clone is basically Git's version of download. Git clone, and then we put in the address of Catapult's, it's ArcSign's repository. I'll just copy it off of here. Again, it'll be in the description, link to his repository, but this is the link right there. And then when you do that, all it's going to do is download the Catapult things into our directory here, and basically just download them. It's not an install. Oh, have I not used it for here? Okay, so when you set up, why do we have to do it that way? That's a little strange. Typically we don't. Oh, I spelled it wrong. Let's Control C. That I forgot the T at the end. Let's try that one more time. Normally, you shouldn't have to set up a username because it's a public directory. Let's try that again. There we go. That's what it should have done. My mistake. Make sure things are spelled right. Goodness. Okay, so now that that's installed, you can do again ls to list what's in there. And now you can see that Catapult is in there. And we actually do want to go in there. So we do cd and the cat and tab to finish typing it out. Hit enter. And now we're in the directory. Now in here, this is where we start building the bootloader, basically, firmware for our EBB. So to do that, it's just like the Klipper setup, only we're doing it in the Catapult directory. Make sure you're in the Catapult directory and not the Klipper directory for this first part, okay? So we're building Catapult. So to do that, we just do the make and menu config. Oops, why am I in caps? Okay, so this is the interface for the Catapult configuration, as you can see right up on top here. So this is where we're going to be setting up things for the bootloader. Now, this really isn't that different from when you set up for Klipper. We're going to be setting up this EBB or whatever device that we're connected to. We're going to be setting it up as a CANbus device from the beginning. Sometimes you set them up partially as a USB, then you go into CAN, but these are all going to be CANbus direct, so we don't need to be using any of that USB stuff. First things first, obviously, you need to select the right chip that's on your board. This one specifically is using a STM microelectronics chip. And it is, the next part is which which chip is it? This one is the G0B1. Right there. We do want to make sure that we have the deployment application installed because that's going to allow us to update and stuff better. Clock reference. Again, these are things that are specific to your board. You got to check it out and make sure that you have what is on your system. This one is correct with the 8 megahertz crystal. And of course, like I said, we're using CANbus. So we want to set the CANbus. Now, lots of options typically on here. You just, again, you must find out what is on, what your board is basically wired up to have. This one specifically uses, if I'm remembering correctly, the PB0, PB1. Offset, leave that to the offset of that it is. It should be default typically. Again, double check your system, your board. CANbus speed. This is the important one because if you remember earlier, we set up at the 1M, if you recalled what we were doing there. So this needs to match. All of your CANbus devices need to be the same CANbus speed, basically, the bit rate. And so this is very important to leave at the 1 megabit is pretty common now to use. You can use slower, but it's not really recommended. So leave it at the 1 megabit. If it's something like a 5,000 or something like that, like I've even shown in my older videos, bring everything up to 1 megabit. All right. GPIO pins, that's up to you if you want to do this type of stuff. It's not necessary, but this just allows you to set GPIO pins for bootloader stuff. So you can, like, if you want to use a pin to force it into bootloader entry. Not necessary though. This one's nice to have, though. Leave that checked because if for some reason it doesn't want to go into bootloader, so you can just double click the reboot button and it will, or the reset button, and it will automatically put it into bootloader mode. So handy to have. The other ones, again, you really don't need to worry about those. Lights, if you want to have a status light, for me, I think it's annoying, doesn't really need to happen. So I just figured leave it alone. Leave it like this, and yeah. If you do want to do a status light, you do need to find out what the light on board is connected to, and you put in the GPIO pin there, okay? That's up to you if you want to. Like I said, I don't want to do it, so I'm going to leave it off. So after you come and set this all up, then you hit Q, and then yes to save it. Oops, I hit yes. There we go. And then, yeah, it's been saved. Now that it's saved, we need to make it or build the configuration. And it is as simple as just typing in make. And that's it. And it's going to build it all out for you. All right, so now that's all done, we can move to the next step. So what we need to do is we go over to our little board. And I know I said we're setting up as CANbus, but first thing we need to do is plug it into USB because we need to program the chip to basically talk. Give the firmware that we just gave it to say use CANbus and don't use USB to communicate. So to do that, what we need is to put it into bootloader mode. All right, so we get a USB cable. They should come with them. If not, just just standard USB, whatever it fits in there. Hopefully this one is a data one. I think it is. Um, Quick little note about that since I mentioned it. Not all USB-C cables actually have the data pins connected. Some of them are designed purely for power. So it looks just like the regular cable, but only the power cables are actually attached up here. So keep that in mind. If you're not getting a communication at all, there is a likelihood that you have a charge-only cable. All right, so look for another cable. Not all cables are created equal when it comes to USB-C, unfortunately. Another thing, when you're using this, as you can see, I don't have any power plugged in. So we're gonna be using the USB power. You wanna make sure that this little jumper is on, or whatever jumper or means of powering the board that you're programming is on, all right? So we're gonna be plugging into our USB for now. This is just so we can flash the board. Like you see it powered up. When you first power this up, you need to put it into bootloader mode. This actually has two buttons on it, so you can do it without having to unpower. If you only have a boot button and no reset button, what you do is you hold the boot button and then put it in. So for instance, if it was like an Raspberry Pi RP2040 type of chip, that's typically how you would do that. But with this one, what we can do is hold down the boot button and then hit the reboot to get it into DFU mode. And that is the device firmware upgrade mode. So I need to get a little close to make sure which one is which here. So this one is boot and this one is reset. So with my fat fingers in here, I got to hold down the boot button and then click the reset button here just once. Keep holding the boot until after, let's see, click, and then release the boot. Okay, so hold boot, click that, then release boot. And it should be in DFU mode. So let's go back over to here and make sure it is. The command to do that is pretty simple, just ls USB. It's going to be list the USBs that are connected. So we got ls USB, and there we go. So yes, we are connected. That's this one right here. So this, if you see this and you're using an STM chip, you're good. You're in DFU mode. If you're using a chip that is a Raspberry Pi RP20, instead of saying this, it's going to say like RPi or Raspberry Pi boot. It's the same idea. It's just a slightly different way of doing it. But it is a device that's in bootloader or getting ready for firmware. So the next thing we need to do is just load up the firmware that we built. Because we're using STM, we're going to be using a DFU flasher, the DFU utility. And I'm just going to make it easy by doing a copy paste. So this command basically just says to set everything up and put the Catapult bootloader in the right spot. And that is the file that we did. So it's the Catapult bin, and we're putting it onto this device. That's what the -D says. Device is that one. If you notice, this number at the end should match to the number that's here. This is the most common number when it comes to these STM electronics. I think that they're all this ID. But by chance, if it's something different, make sure to replace this last number with whatever is there next to your DFU mode. Okay? So once you have that, you hit enter and it should start burning everything through and you're good. Now you will possibly get this like error during download status, get status. Don't worry about that. You see this previous line where it says file download successful. If you see that part, it worked. The reason why it does this during download get status is because it's looking, what it does is after it downloads, there's an option in this DFU utility that will check to see if it did indeed download. But because it automatically reboots and we don't have a pin that's being held to keep it into boot mode, when it reboots, it goes out of DFU mode right away. So it can't check the status because it's no longer in that mode. Hopefully that makes sense. So it's not an error. It doesn't mean that it didn't work. It just means that it wasn't able to verify that it worked, but it did. Okay, as long as you see that successful and it went 100%, you're good. If you get all sorts of other strange errors, like a whole page of weird errors, red text, anything like that, that's something different. Double check that you did everything the same way and try again. But now we're good. We can unplug the board here, get that unplugged. So we don't need to use USB anymore. And we can remove the little jumper there. We don't need that power. So keep a hold of those things, though. They're very handy to have, especially if you need to boot something up or flash something again. So now this thing is programmed, if everything went well, to be communicating via CANbus. So we're almost there. It is really that simple. So I'm going to go and grab the cable to this. And while I do that, why don't you check out PCBWay, our channel sponsor, and we will be right back. If you're someone who loves tinkering, designing, and creating, you'll definitely want to check out PCBWay. PCBWay isn't just about PCB manufacturing. They've got a wide range of services to cater to creators just like you. From crafting intricate prototypes using many forms of 3D printing to precision machine parts through CNC machining and so much more, PCBWay has got you covered. A really nice part is their online quoting system. It lets you see the cost estimates for the services you need, allowing you to plan your projects without any surprises. As for quality, PCBWay takes it seriously across all their services and do their best to ensure all your designs will meet the highest standards. Beyond services, PCBWay offers a supportive community. Their forums and dedicated support team are there to help you to navigate through your creative journey. If you're intrigued and want to know more about PCBWay services and how it can benefit your projects, check out the link in the description. I want to give a big thanks to PCBWay for sponsoring this video, and now let's get back to the video. Okay, welcome back. So I got my cable, and I have this homemade cable. It's just a bunch of different wires wrapped up, and I got one end of it for the CANbus, so it can fit into this plug here. And then I got another end right now. I'm just powering it up with a little 12-volt power adapter, just for demonstration purposes. Obviously, you would connect your power cable to your 24-volt or whatever your voltage you're using to power your hot end, or whatever board you're using, right? So we have that, and we have, actually, let's power down this first, so it's not connected while we power up, or we connect. So we want to get the CANbus cable put in there, obviously. It is important to check of which orientation you put your wires in. So when you make these things, you want to make sure that your CAN high and low correspond to the high and low on your things. If you face it like this, you have your high on the top here, top right, left corner, low on the top right, your positive power input on the bottom, and your negative on the bottom on this side. Okay, so make sure that your cable is set up that way. Don't pay attention to my colors. I have my own color schemes that I use. Colors really don't matter. They're just used for tracing lines. But just make sure that your power lines are in the proper spots. Of course, you don't want to short things out or never want to give 24 volts to your CANbus line, because that's done. You'll kill it. So double check that your power is in the right spots. But I've used this many times, so it better be in the right spots, because it was. Also, while we're having the board up here, you want to make sure that your 120 resistor jumper is in place. So I'm not sure if the camera picks that up, but this little header pin in there is what they call a termination resistor jumper. It's not built into this little guy. This is just a handy thing to hold on to, but you want to bridge these two pins right here. And this is done only if this is the last board on the CANbus line. And I say that because if you notice, this one specifically has two pins right here. Those two pins are linked exactly to these. So you can technically put another set of wires off of these, and this is the high and the low CANbus, and then go to another one of these. So you can daisy chain, basically, as long as they're all in parallel, you can connect tons of these things. You can technically make a whole printer with just a bunch of these little boards. Pretty interesting. But you know, each one has its own driver built in, right? So you can do an X, Y, Z, and toolhead all with these little boards and have a fully functional printer, believe it or not. Because CANbus uses a bus system, bus meaning that it's all in parallel, and then the devices just kind of branch off of them. And then you leave the termination resistor only on the, or you only install it on the very last one in the line. So the way it works is on the very first, which actually this one has one built in, so you don't need to add one there. This is the first, and this is the last. So that's where you have your terminations on. But if you wanted to take off of this here and add another one and maybe 2 or 3 more, then you would take this jumper and put it only on the last one. The rest of them will be open. You don't need to have them. Only one on the last one and one on the very first point. Okay? But yeah, we're doing only one, so it has to be there. And it is a typical installation. Normally you don't have more than one tool head, but a lot of, there's a lot of new tool head systems out there that are going to like tool changers and you want to do them all CANbus, you can daisy chain them all together and have all of them connected through the one chain of CANbus stuff. So pretty nicely done. Anyways, enough of that. Get your other end plugged into there. Right? So now we got them both plugged in, and then I'm going to give it power. Hopefully nothing pops. There we go. We got the board powered up, and we should now be able to query that we have CANbus set up. Now, keep here because we still need to get Klipper running. Right now, all that's running is the bootloader for Catapult. We have not finished installing Klipper yet. Before we do that, we have to do a very, very vital change. If you remember earlier when I started the video, I said that these two ports are not usable at the same time. So you have SPI or CANbus, but not together, right? Now, let's open up here. I've already removed the screws, but down here, underneath here, you have this little door that opens up and it's got some information in there. And it's letting us know on this side that there is basically a chip select choice. So you get to select which chip is being used. It's a little difficult to understand what's going on, but basically the easiest way to understand this, let's get up close. The white areas on these are if you're going to be using CANbus, and the black areas are if you're going to be using the ADXL or the SPI port. Okay, you see that? So we got CANbus and sorry, the CB1 and the CM4. So they're different positions because they're just different pins on those two boards. So depending on which one you have, you'll move them to different things. So easiest thing, because we're talking CANbus, if you have a CB1, I believe the CB2 also, although the CB2 might be more like CM4. I have not tried it here. You can just switch both ways and make it happen. But on the CB1, you want to flip the switch to where the white position is on here. And what I'm talking about, let's see, can I zoom? Let's get this in. So we're talking about this little switch right here, that tiny little guy. So I'm just going to use a little plastic thing here. And it's kind of difficult to see, but there is a switch right there. And you want to flip it that direction. This gives it basically, it says use this SPI, not that SPI. That's the easiest way to say it. All right, so that's vital. Now, if you have a Raspberry Pi, then you would put it in, it'll be on the other side over here for CANbus. That simple. And I think, honestly, if you use the CB2, it should be over in the other position also. But again, it doesn't matter. It's basically it's going to work or it's not going to work. It's the way that's set up. So let's see if I need to reboot. Yeah, I might need to reboot, but let's see if I can just query now to get CAN0 set up. I'm not sure. I might need to reboot after flipping that switch, but let's try it first here. So the command is, you can use either the Klipper command or the Catapult command. They're virtually the same thing. It's just this Python script that runs a query on the CAN0. Let's see if it actually does it. It's going to check. No, I need to reboot. So because I switched over, it's not connected to that CAN. Let's do a quick reboot here. Yeah, we're going to query. Actually, because we're using the CB1, the CB1 requires a thing that's called the overlays. Just remembered that. So we want to make sure to turn on in the CB1 the ability to talk to your SPI chips, so or to the CAN transceiver. So what we need to do is change directory. Actually, no. What we want to do is sudo nano, and we're getting into a specific folder. This is the boot directory, and we want to get into the board environment. We just do capital B and then hit tab. This is for the CB1 and the CB2. They have these board environment texts, and so you want to get into them. Let's see, we got overlays. Actually, it looks like it's already done on mine. So this is the one that's important to have open, to have commented or uncommented. Like it says right here, this is the SPI to CANbus module. So we want to make sure that that is active. If you have other things, like say for instance, you have this overlay active. This is for the LEDs on the PAD7. If you have it like this, let's just bring it down like that. You can't. They don't I don't remember if it's important on the CB1 or not, but typically when you have overlays, you can't have them on multiple lines like this. They all need to be on the same. So if you're going to use this overlay, what you need to actually do is add, you go to the end here, oops, you give it a space, and then you would do the MCP 2515, like that. So you do a space, the space is important, and then that, no commas or anything like that. And actually, if you go down, it should say something about that. Yes, like here. So this last line here, it says that overlays, basically it says write the config after overlays with separated by spaces, right? Basically what that's meaning is that it needs to have everything on one line. Otherwise, all it's going to do is read whatever the very last one is, and it won't work with all the rest. Okay, so let's just get rid of this one because I don't. Oops. 82. I don't care about the LEDs at the moment. We'll just do that, and we'll have just the one overlay, and then we hit Control S for save, and then Control X to exit out. Now we should be able to do the query of CANbus UUID number. So hopefully that works. Let's see. So yeah, there we go. So we got all that set up. It checked for any nodes and it detected. If by chance you get an error of it not being able to find CAN0, just reboot your system and try again. Obviously make sure that that board environment, if you're using the CB1, is set up properly. So yeah, there we go. We now have our UUID. This number is the specific unique number for the board that you're connected to, really. Each one should have its own unique number. And yeah, so now we got that number. Now what we need to do is go into Klipper. So we can cd ... that takes you back, and then / and then Klipper. And now we're in the Klipper directory. And in the Klipper directory, we need to make the Klipper firmware. So we just do the same thing, the make menu config. There we go. And now we are in the Klipper firmware configuration, right? Looks exactly the same as the previous thing, but now we're doing it for Klipper. And it really does follow the same stuff with a couple little caveats. So first thing, we want to make sure that you're in the right chip. So it is an STM chip, but it's not that one. It is, where did it go? This one here. Enter. That is correct. The clock reference is not correct on that one. This one is an 8. Communication is CANbus, but like we said earlier, it is on these lines. And that CANbus speed is too slow. That's not matching the previous one that we're using, so we want to make sure to make that correct. 10, and then we got 1, 2, 3, 1, 2, 3. Yep. Okay. So 1 megabit. We're good there, and the rest can be left alone. And that's it. Again, all of these are up to your board. It is important for your board. And you do want, for the bootloader offset, you do want to have that set. Because if you don't, it's basically saying that there's no bootloader, or don't worry about the bootloader, and it could overwrite the Catapult bootloader, so don't do that. Make sure you have the offset on, okay? And yeah, that's all we need to do with that. Then you hit Q for quit, Y for yes to save it, and then we want to do a make. Depending on if you've flashed things with Klipper before, it's smart just to do a make clean. And that just cleans up the folder to make sure that you have a nice clean folder, no leftovers from the previous thing. And then you do the command make, and this will make your firmware. Okay, that is now finished. I did notice one thing. On this board, I have not updated Klipper. This is a slightly older version. For our demonstration, that doesn't really matter, but make sure that you get your Klipper system set up and updated to the newest version. That way, you know, you have the newest version on your board. Of course, because now we have Catapult on here, it makes it easy to flash updates. So it's not a huge deal, but it's nice to start with something that's obviously up to date to begin with. Anyways, that's going to be on the scope of this video, so it doesn't really matter. I'm just showing you how to get things going, but make sure you're up there. Anyways, so now that we have it made, what we do need to do, actually, let's just do another query just to make sure that we have our UUID, because we do need this number. It is very smart to put this number in a safe spot somewhere like in a notepad or write it down somewhere because we use this number often for flashing things. We also need this number when we install or set up our printer configuration for this board. Okay, so make sure you have that. It's very important. So I'm just going to do a quick copy and then let me just paste it off the side here real quick. We're good with that. Anyways, so now that we know our number, we got our UUID. This is a good sign. When you have UUID, that means that CANbus is working and communicating. But let's get Klipper installed. So because we're using Catapult, we're going to use the Catapult script, basically, that does the flash. And it is on Catapult's directory website or repository website. So I will obviously have a link down in the description. But this is it here. And what we're saying is use Python 3 and then use the flash tool script. Same thing that we were using, as you can see up here, for query. But instead of querying, we're flashing. As you see, it's all this rest the same, right? So we're going to flash. And then what we want to flash is this file, which is our Klipper firmware file. That was what was just made. So it's in the Klipper out, klipper.bin is the firmware file. Then we want to flash it to a UUID, a device. So at the very end here, we want to put in our UUID. So you can, typically, if you're using terminals and stuff, you can just highlight it and then right click and then right click again, and it'll put it there. So that's the device that we're flashing to. So let's flash. Hopefully this thing works right. It should be a fairly quick thing, so it'll flash and then gives you the verification that it was complete. So as long as you see all this, you're good. You are now flashed and you have Klipper running in CANbus. So to verify that, we can now go to, let's just go over to here possibly. Let's see. Let's just do, what was our things? We got 192. We're going to go into the main cell. What is it? 27, I believe. So we come into our main cell. Right now, obviously, we don't have a device plugged in because we haven't set it up. Sorry, not plugged in, but we don't have it here because we don't have it set up. So we do need to set it up in our printer configs. Now, this part is where it comes to, of course, you need to set up your own stuff depending on your board. For instance, I can use the Bigtreetech thing here as the example. So that's what I'm using. And they have a, let's see, in the hardware. No, where do they have it? Here it is. So you got your sample configurations. I have specifically this board is the 1.1 config. So we can just drop this whole thing in there, which I guess we could just do. So let's just copy that. And I'm actually going to set up a new, since this is the ebb.cfg. And then in our printer config, we will want to include that. Let's see, we got these guys include, and we did the ebb document. Just save. Let's not restart just yet because I didn't put anything into the other one. So what we've done there is just pasted in the generic thing. So it's not really going to do much because nothing's connected to it, but it basically just sets up all the basic pins. And the important part is this one right here. We are not using serial, so we want to hash that guy out, or you can just delete that whole line. Actually, I'll just do that just to show you. This is not necessary. What is necessary is this guy here. Let's uncomment that. And this is the CANbus UUID. But of course, it's not the generic one that's there. We don't need that one. We need the one, whatever one it is that you got in the query. So it's not going to be mine. It's going to be whatever yours was. Paste that in. Now we can save and restart. And hopefully we don't get any weird errors. Might get a temperature error. Pretty sure it's the ADC. Yep, we have a temperature error. So let me fix that real quick. Let's see, where's the minimum temperature? I'm just going to set this to a minus right now because basically there's nothing connected. There's no thermistor, so it's getting a super low temperature. So I'm just going to put this to lowest temperature it can be is minus 2000 or 200. So it should get rid of that error. I don't think there's anything else that, yeah, okay, we're good now. So we don't have the error. And here's the board. And you can see that we're all up and working. Everything's good. If you come into here, you can see all the stuff it knows what everything is and all that good stuff. You can see here's the CANbus. It is working on CANbus on that frequency, clock frequency, yada yada, all that good stuff. So that's it. You're connected. If you followed this and you came to this part and you're able to see your board in there, you're good to go. Now all the rest is up to you. Now you have to configure your stuff, which I have some other videos that show a little bit about what the printer config is and all that fun stuff. But this was just to get you going to get CANbus installed. If you're probably doing the CANbus and you're using these things and adding stuff, you probably already know about all that, so should be good. If not, check out those other videos. And that's how you get CANbus working on the Bigtreetech PAD7 without needing any other special equipment. Pretty simple, right? Hopefully this video was very helpful. Drop any comments down below if you have any questions, you weren't too sure what was going on or what commands were and whatnot. I can help you out, no problem with that stuff. I will put links down in the description. I'm actually going to put what's it called, the Esoterico CANbus guide, because that's where I got a lot of the newer updated versions of things where I was setting up the transmit queue length and stuff. So I want to give him credit for that stuff. Esoterico has done an amazing job making this guide, so definitely check that out in the description there. If you like it, you give him a donation or whatever. He's got a little Ko-fi, whatever, a donator thing. So go ahead and drop him a like. He's not sponsoring me. He does not know I'm making this or even plugging him, but he has been a vital help to the or an asset to the community here, for especially for all things CANbus. So I want to drop him a free just shout out and tell everybody, check his stuff out, give him the support. He has been just a pillar in in this whole community here for CANbus setup. It's amazing what he's provided for everybody and how easy his guides are if you just read through it. Also, I will have a link to the Catapult repository, so you can check that out and get that information. So all those things that I've been plugging in here are going to be basically shown in those two guides. So hopefully this video was helpful and you got all the information you needed. If you have any questions, feel free to jump down into the comments and let me know. Or if you have any suggestions or missed anything, again, comments are great. I will help you as best as I possibly can in there, okay? So don't hesitate. Check out PCBWay. They are awesome to me. They are really helping me continue my channel, being able to get things to, like extra boards and stuff to show you how to do this stuff. Again, thank you for watching. Any questions, comments, leave them down below. Give those likes, subscribes, all that YouTube jazz. And until next time, get out there and go make something. Thank you for watching.